Now we're going to talk about dealing with inscribed angles that's intercepting a diameter. So let's talk about that. So if an inscribed angle intercepts diameter, then it is a right angle. So first of all, let's go over diameter again. So back to our guiding notes. A diameter is a segment that has endpoints on a circle and it passes through the center of the circle. Okay, so that's what your diameter is. So here, it says the measure of angle BAC angle right here is 90. Now the reason is it's an inscribed angle, so the vertex is on the circumference of a circle. Now because the intercepted arc right here, these endpoints are part of the diameter, that's your center, and it goes through the endpoints, then that means that that angle is going to be 90 degrees. So now we're going to look at 3 examples of when we could actually use this information to help us. So for example 1, it says determine the value of x. So x is right here, it's 6x. This is at angle G. So angle G, the vertex is on the circumference of the circle, but I don't have an intercepted arc to help me like we did for the last video. So here, if I notice the intercepted arc right here, the KN, these points are the diameter. This is the center of the circle, this is circle O, and these are the endpoints. So because if an inscribed angle intercepts a diameter, then it is a right angle. So that means this angle G is going to be a right angle. So that means this has to be a right angle. And what do we recall about a right angle? That means it's equal to 90 degrees. So I'm going to have, okay, so 6x equals 90. This angle has to be 90 degrees. So now I'm going to solve for x. So what's attached to it is a 6. The operation is multiplying, so do the opposite to get rid of it. You're going to divide it by 6. This divides out to 1. So you have 1x equals 90 divided by 6 will give you 15. So x will give you 15. Okay, so next, example 2. Determine the value of, determine the value of W. So let's look at where W is right here, angle T. The vertex is on the circumference of a circle, so it's an inscribed angle. So first I check, do I have, across from it, do I have an arc value? I don't, so I can't take half of that. However, the intercepted points of the angle E and M, it's from the diameter right here. That's the diameter of the circle. So that means that again, this angle has to equal to 90 degrees. So 4W minus 10 has to equal to 90. So this is your 2-step equation. Always take care of addition or subtraction first. I have a negative 10. So that means I do the opposite on both sides, which means I'm going to add 10 to both sides. So that could cancel out. You're going to have 4W equals 100. And the last step is I want W to be by itself. So if I cover W, I still have that 4. The operation is multiplication, so the opposite will be dividing. I'm going to divide both sides by 4. So that divides out to 1. You have 1W equals, it'll be 25. Okay, so that's how you find it when your inscribed angles intercepting a diameter. So we have one more to go. Example 3. Okay, so we have part A and B. Part A, determine the measure of angle R. So I'm looking for angle R right here, which is a 3x plus 4. Now, this is a little different. So let's go over. We're looking for angle R. Angle R is an inscribed angle. I go across, I don't have an arc measure to take half of it. And let's check. The endpoints does not go through the diameter. It's not a diameter right here. Where is my diameter? Right here. This is the center of the circle, and it's not drawn to scale, okay? So this is the center. So that means what I'm gonna highlight right now in blue, this is my diameter. So that doesn't mean R is 90. If you go back, it says if an inscribed angle intercepts a diameter, then it is a right angle. So this is my inscribed angle. It has to intercept the endpoints of the angle, has to go through the diameter. So if we look at example 3, if this is my diameter, these are the endpoints of an arc, of an inscribed angle. And which angle is that? It's S. Angle S. This intercepted, this is intercepted. So these points from the diameter is part of angle S. So that means angle S is the one that is 90. That's 90 degrees. But again, how does that help me? Because I need measure of angle R, then I need measure of angle T. So again, we went over the last video, a triangle, don't forget that. A triangle, the sum of the angles have to add up to 180. So let's think about it. This is 90. I need to figure out what do the remaining angles have to equal to. So if a triangle is 180, if I subtract this angle 90, I'm left with these two angles have to equal to 90 degrees. Because these two add up to 90, and that is 90, that'll equal to 180. So to find measure of angle R, we're going to take this angle, 3x plus 4, plus this other angle we have, 6x minus 13, has to equal to 90 degrees. Because that was already 90, so the leftover is these two have to equal to 90 in order for the whole triangle to be 180. So now we're going to go ahead and solve. So I have parentheses. So every time I see parentheses, I need to think, okay, is there any number I could distribute? Because you don't see any number in front of the parentheses, that means just 1. So technically, you're just distributing by 1, and 1 times anything itself. So because you don't see any numbers, let's just drop the parentheses to make it easier. So you have 3x plus 4 plus 6x minus 13 equals 90. Now we're going to go ahead and combine like terms. I see 3x and 6x. They're on the same side, so I just combined them. So I have 3x plus 6x, so that's going to give me 9x. Then I have, I have 4 and negative 13. I combine those two terms, I get negative 9 equals 90. So now it's your two-step equation. Negative 9, I always take care of addition or subtraction first. So here's my variable. What's attached to it is a negative 9. So the opposite would be adding 9. So you have 9x equals 99. I want x by itself. This is being multiplied, so do the opposite operation. We're going to divide by 9. So this divides out to 1. You have x equals 11. You might think, oh, yay, I'm done. But always go back. You're looking for the measure of angle R, not what x is equal to. So all you got to do, this is angle R. So angle R is equal to 3x plus 4. Now, the only thing that couldn't help me is because I didn't know what x is. Now that I know what x is equal to, I could just substitute in that value. So I have 3 times 11 plus 4. That's going to help me find angle R. So I have order of operations, PEMDAS, we're going to multiply first. So I have 33 plus 4. So that means it's going to equal to 37 degrees. That's the angle R. Okay, so now, of course, there's more than one way to approach this problem. But the easiest way to find measure of angle T is just plugging it in. Angle T is 6x minus 13. So there's two ways. You could either just substitute it in, or if you could do 180, the triangle, minus 90 minus 37. So there's more than one way. I'm just going to substitute it in. So the measure of angle T, it's 6x minus 13. So I'm just going to substitute it in. 6 times my x, which was 11, minus 13. So again, order of operations, we're going to multiply 66 minus 13. So that means the measure of angle T will equal to 53 degrees. Now, you can always double check to see if you did it correctly. We said a triangle adds up to 180. So this was 90 plus 37 plus 53. That will give you 180 degrees. And that's exactly how much a triangle's angle is added to. So this is what happens if you have an inscribed angle intersecting at a diameter.